Good afternoon, everyone, and especially thank you, ISEC, for giving us this opportunity to present our ongoing work in to this outstanding audience. Before I start, I would like to congratulate, by the way, the organizing committee for doing a brilliant job of not just planning, but also executing ISEC so well, despite all odds. And I believe you have set very high bar for other conferences to match in this new world where hybrid conferences will and must become a norm. So snow leopards are known as the ambassadors of the mountains because they cross international borders without passports or visa. Everything about the species, other than perhaps its size in comparison to most other members of the genus Panthera, is enormous. They have enormous distribution, enormous home ranges, enormous fur, enormous paws, enormous nasal cavities, and of course, an enormous tail. Whether it is the prime minister of a country or a taxi driver, the first question they ask you the moment you reveal yourself as someone working on snow leopard conservation is, so how many snow leopards are there? It's a bit embarrassing that despite more than 30 years of solid research and some of the most successful community-based conservation programs, we still do not know how many snow leopards are there in the world. The numbers vary from one educated guess to another. So in 2017, the heads of states and their representatives from each of the 12 snow leopard range country came together in Bishkek, where they endorsed what we call as the Bishkek Declaration. And now, the Bishkek Declaration listed the need for scientifically robust estimation of global snow leopard population. It was an important decision because just around that time, IUCN had downlisted snow leopards from endangered to vulnerable. Going back in time, I can never thank ISEC enough, for it is the ISEC in 2016 in Seattle that helped us initiate a remarkable collaboration with the University of St. Andrews, what I call as the Mecca of population ecology. Now, snow leopard is an elusive species that is difficult to be seen, but not so difficult to be photographed on camera traps or followed to find its spoors. Both allow the species to be identified as individuals. So on country's instructions, the GSLEP program empaneled 12 experts from the field of snow leopard ecology and statistical ecology. And who better to lead this panel than the daddy of spatial capture recapture, Dr. David Borchers. So David and his esteemed panel, including other members such as Daryl McKenzie, James Nichols, Chris Sutherland, and others, came together and developed a detailed roadmap to achieve the mammoth task of estimating global snow leopard populations through the initiative, what we now call as PAWS. Essentially, the task in their hands was to simply estimate how many snow leopards in 2 million square kilometers spread across 12 countries. Today, I'm presenting briefly how PAWS is helping us conduct record-breaking surveys just by showing the work being done in one country, Mongolia. Most of you might have heard of Mongolia, may have been to Mongolia. It's a landlocked country in Asia that's 18th in size, but 136th in terms of human population density. And it is also known to have the second largest snow leopard population in the world, next only to China. So our first challenge in implementing PAWS was to know where snow leopards are. Now, the maps we had were binary maps based on key informants or experts, to say so. In other words, a snow leopard made it to a mountain range contingent to whether an expert made it there. Now, with all due respect to experts, there obviously was a problem here. Snow leopards do have some clear weaknesses. They can't live without mountains and they don't live in forests. So we brought the representatives of several organizations and universities supported by the government of Mongolia for a capacity building and planning workshop in May 2018. The goal was to figure out first the areas where snow leopards are and how they are distributed across the country. What followed was nothing less than a miracle. 12 teams with a total of 60 researchers and 126 rangers conducted science surveys by traversing 19,924 kilometers of transects in the next 6 months. The surveys covered more than 1,000 sampling units that represent 500,000 square kilometers across Mongolia's potential snow leopard habitat. This was the most spectacular data I had personally ever seen. Following the survey, we brought the organizations together one more time, this time to estimate the probability of snow leopards using the sampling units. A candidate model set of 27 ecologically meaningful models was developed and run. Ranking models based on minimum AIC helped us choose the best models that provided us an estimate of snow leopard occupancy as a function of very reasonable and very explainable variables such as terrain ruggedness, vegetation, altitude, area under forest cover, and so on. Ruggedness of surveyed segments and mode of survey correlated with the probability of detection. In other words, models seem to behave fairly well. So what you're seeing here is perhaps the first comprehensive estimated distribution map of snow leopard occupancy from entire Mongolia. Now, it's fascinating how it compares with the historic binary or Maxent-based probabilistic maps that assume perfect species detection. We created several thresholds because that's how human mind thinks to determine the best possible match between the three distribution maps. Now, even when chosen to maximally agree, nearly 14% of these cells were differently classified by occupancy, expert maps, and the probabilistic maps using presence-only data. Broadly speaking, both the expert map and presence-only maps differed from the occupancy map. For instance, both missed the area in the north where snow leopard occupancy was likely, according to the recent surveys, and we later were able to confirm it with camera trapping. There were other discrepancies, such as this one in the eastern Altai range, showcased as a contiguous snow leopard habitat, but estimated very low on occupancy and also camera trapping. There were other differences in the southwest and West Mongolia between occupancy, expert maps, and Maxent-based maps. Now, occupancy estimates are limited in their ability and can only help estimate species distributions. The local NGOs and universities have already camera trapped 26 sites in the past 2 years, spanning an integration area of roughly around 115,000 square kilometers. Now, a recent publication highlights how it is quite likely for people to be attracted to high density areas when conducting camera trapping on snow leopards, especially when surveying small study sites due to, let's say, logistical constraints. So what such selection can do is not surprising, but extremely valuable to inform the pause process. So here the black dots represent the camera trapping surveys that have already been completed, and they cumulatively cover nearly 25% of the entire snow leopard range in the country. Now, one would assume that with such a coverage, the data should be sufficient to get a reasonable estimate of snow leopard abundance. This is where we brought in our stats gurus who developed a hypothetical expected activity center surface showing expected number of snow leopards per 15 by 15 grid cell with a mean density of half snow leopard per 100 square kilometers. Then they created the realized activity center density surface. So the image to the right shows the locations of a simulated snow leopard population with a known 1,328 individuals. Using a simulated camera trap study of the population to the right, assuming that any animal whose activity center is less than 12 kilometers from a camera is detected, we did count how many activity centers appear in the areas seen by our cameras. Now, because we knew exactly how many cells are visible to cameras, we could calculate an estimate of average snow leopard density per cell. And this estimated density was then used to estimate abundance across the entire survey region by multiplying the total number of grid cells. What we did find was that the net effect of placing cameras in high density areas and then using them as if they were representative of the whole region can lead to a substantial bias. For example, in this case, the known population of 1328 individuals was estimated, the simulation estimated the population to be 1,664, an overestimate of 25%. So we then simulated the population and its estimation using spatial capture recapture analysis 500 times. And the histogram on the right shows that the range of errors on an average still recorded a positive bias of 23%. Now, ideally, one would design the surveys in such a way that they could be balanced, that they could use balanced sampling approach right from the beginning. But each country, region, or NGO has its own priorities and commitments with donors, funding partners, and their own plans. Some areas must be sampled out of sheer necessity, and we cannot expect all NGO partners to leave everything to just start conducting surveys as per the macro sampling design advised by PAWS. Now, this is where the adaptability of the current sampling guideline comes in very handy. Spatial capture recapture analysis of completed surveys are being used to inform decisions about where and how much more sampling is required to achieve density and abundance estimates with a desired level of precision for the entire country. As we speak, partners in Mongolia are out there conducting the second last round of sampling with camera traps. So that's all really. I mean, the entire process presented here is available as cheat sheets and a Shiny app on the website of the Global Snow Leopard and Ecosystem Protection Program, because we really hope other countries are able to use these methods and the sampling design. And with all the 12 snow leopard range countries currently putting their efforts towards PAWS, we hope that soon we will be in a position to reply to a prime minister and an Uber driver when asked how many snow leopards. With that, I would like to stop here. Thank you all. And I'll be happy to answer questions, but I can also assure you that even though I may not be able to answer all questions, I feel empowered to be able to do so with the help of our incredible team. Thank you.